Hi guys, continuing our DSA course on yeah topic topic you will guess by looking at the problem really soon. Given reach a given score line. Okay, okay, it's taking a bit to load. Okay, so reach a given score. So you are given like total score n given. Find the number of distinct combination to reach this given score. Okay, so consider a game where player can score 3, 5, 10, and 1 more. So this is what player can do. He can make score 3, 5, or 10. You're given a score n. You have to just make number of different combinations that reaches to, let's say, yeah. Now, for example, if the total score is n, what is n in this case? Right, 3. Okay, so there are n is equal to 8. Okay, I think this is not a good way. Like they have given test cases and then for each, but what we have to do for one integer n, I have to return one integer answer count. For 8, like how many ways to reach 8? Yeah, and it's like kind of a dice problem only, but instead of 1 to 6, you make 3, 5, or 10. Okay, so let's see. Yeah, if I make 3, then I'll call on the number of ways to make 5. If I make 5, I'll call on the number of ways to make, yeah. So basically, your vector is very fine, and again, you can take a thing more than one time. Sometimes you can take three, so many times, right? So if I have this solve function and current number and a vector, okay, vector, and over here, which will have stored as 3, 5, and 10. If current is equal to 0, return 1. Okay, there is one way. Okay, if you had made this current equal to 0, return 1. Okay. Basically, you got one way of doing this, making the sum exactly this. Now, yeah, what are the three things you can do? You can not three things, but you have an option of solve of current, comma. If you don't do the take anything, right? You don't take v of id. Okay, and I think we should write if id becomes equal to n, return 0. In my case, it is 0, 1, 2, 3. Okay, you can go for id plus 1 and current and v. Okay, this is the case if current is lesser than, I mean greater than or even equal to v of id. So you can call on return of max. Id remains id current minus v of id, comma v. This how much you have taken one thing, right? No, it's not like this, but return, I think, total number of ways of doing this plus total number of ways by doing this. Else you return basically, yeah, you just return solve of id plus 1 and current and current equal to 0. Okay, I know what it is, but we'll be calling something like id is 0 initially, current is n, and v is v, and vector I actually create v as 3, 5, 10, and this id current return dp of so by the time I think everyone knows what the topic is, dp, right? So yeah, but this is a general dp problem, and we shouldn't have like, yeah, because there are multiple couple of ways for approaching this. One way is this, and I'd feel like tabulation is the best to go. Yeah, but still, like, I'm doing a kind of a recursion, but I think tabulation is best for this. Like, every time you can take this and this, and as soon as you go 0, you return. Yeah, so that's what you want to do. But this is also fine. As you can see, this is fine. Just to move to the next problem, which is largest square formed in a sum matrix. So let's look out for some other solutions, like a general tabulation solution, which I feel like it is, I'm again like saying it is like a dice problem where you can have select 1 to 6, but yeah. Or this is again like a jump game, not jump a game, but house robber, not even house robber, just climbing a stairs. You know how climb stairs for problem. So you create a vector of int of dp of n plus 1, let's say dp of 0 you say is equal to 1. You want to return a number of ways to make a dp of y, n, and you know that for anything for int I is equal to 1, I less than n, I plus plus. The number of ways to make a dp of I plus equal to is equal to number of ways of going from I minus 3 plus dp of I minus 5 plus dp of I minus 10. If that is 0, that is 0. Yeah, then you can just say 0, right? If I minus 3 does not exist, then 0, man, whatever. If I less than 3, then you can say 0. I is equal to 3, you know the answer. I less than 5, then do 0. Else you know the answer. And I less than 10, you do 0. So this is the second way which you can progress. Like now, you have to create a next, yeah, switching to the next problem. Given a binary matrix, take it to the docs. I think this is a good problem. Given a binary matrix of size int of n, find out the maximum size square some matrix with all ones. So yeah, a matrix having all ones, and yeah, our square matrix. Okay. So what you can do actually, like how, um, like again, now we know the topic obviously. And this is again one of the famous problems. So again, that connects to the topic that how we have to approach DP to solve this. So that lies under the observation that if let's say you have one particular one, right? Then you have one, and then one, and one, and one, and one, and one, and one. Now the answer for this is just one. The answer for this is again one. But why is it one? Because this is a rectangle, right? What is this? A square which you can get. Uh, this is a square which you can get like just one length square. Okay. Now, what about this? How the answer for this is 2, and the answer for that was 1. Answer for this was 1. Answer for this was also 1. So you said something like, if that is 1 and if this is 1, so we can say like, yeah, that value stores the number of basically largest square matrix that it has, such that square proceeds like this. It has a starting point. Let's say this as a starting point. So this is the starting point of the square and this is the ending part of the square. So this is the square of x cross x, n cross n, whatever. Now that can be incremented just like why it can be just incremented, because let's say I already have that. If I have a particular like a range of ones in this row on this column, then I'm good to go. Okay, good to go. So, answer for this is actually like there is a square matrix of size this and this. Okay, gotcha. That is basically largest squares and matrix ending at this point. So it will have some length over here and some top length. So answer for that, let's say if it is 3. So there is 3 till this point, 3 till this point, and that satisfies that this 3. There is at least like 3 of now what does this represent, like the answer to this point? That is again let's say 3 comma 3, but yeah, let's think about this one. He will say the answer for this is 2. Okay, good question. He will also say the answer for this 2. True question. How do the answer for this comes up? He said that the answer for this is 2 plus 2. Okay, that is fine. So which means like there is a length 2 over here. Okay. And like, these two are fine, and the 1 1, and these two are 1 1. That is what he thinks. Then this says that the answer for this is 2, which means this is 1 1, this is 1 1. Okay. This says this is 1 1, this is 1 1. Okay. So we got that as one, that as one what we wanted. This is one, and this is what we wanted. This is particular one, so it can like take this length from this, some length from this side, and basically obviously this. So if you have so for this particular point, I need to see the minimum of 3 things for I comma j. I see I minus 1 comma j. I see I minus 1 I comma j minus 1. I minus 1 comma j minus 1. So r minus 1 comma j minus 1, I minus 1 comma j, I comma j minus 1. Okay, now yeah, that is what is needed. So if I implement this solution, so again, you will take maximum of the minimum of this comma this comma. If that is this, then you can increment by one. Yeah, minimum of all this and then one plus minimum of all this. I think that's how you have to proceed. Sure. So let's create a DP nm. We can return max. X is 0 and ये क्या एरर है इसमें मुझे समझ नहीं आ रहा. इन फाइल included like what? Compilation error है. अच्छा ठीक है. Oh yeah. So basically -1 पे कॉल करो. कंपाइलेशन एरर है यार. वो रन टाइम एरर में चीट कर. अच्छा मिनिमम में यार इसको यू हैव टू टेक दैट. वन प्लस करना ये इम्पोर्टेंट है. चलो लेट्स मूव टू द नेक्स्ट वन. पाथ इन मैट्रिक्स व्हाट. या लेट्स सम इट अप. So this is the approach and general question just for each particular element which is one. You see around the digits like how much square which you are already getting from I minus 1, j minus 1. There might be two cases. One case where you increment the square length and one case like this. Currently this was having 2 and this was having 2 and this was having 2. So that suggested me to increase the length because yeah everything you are getting like this 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 region you are getting which has already has 8 ones and this particular one can create the ninth one. But when you see about this, so this has let's say the yeah I minus one common j like when you see three of the neighbors, one neighbor has two but other two neighbor has one, so that's why the answer for this is again two. Like even if I have three in this line but neither I have like yeah two above, so I only have one above, so that is one thing. And similarly this also has only one like it has like one over here but does not have one above. That's what's needed. So that was the reason why the answer for this particular thing is 2, this particular thing is 3, and that's how you go about it. And let's see the next one. And I think this we have already done. Yeah, this we did today only. No, you start from any column, any row in the zeroth, yeah, one column in the zeroth row, and you have to go to n minus one row, and yeah, this is the approach written over here for this key for yeah like as soon as you reach n minus one return value, and j can go out of bounds, so do minus one for that and return maximum of like yeah one maximum value if you go to this. Or option is like the solve I plus one is always there. You can change your j like in these three ways I j plus one minus one or same. So that's about it. And minimum removals to make array max minus min is equal to less than k. Okay, so currently this array has something maximum something minimum, and this would be a bigger thing. But when you decrease not decrement, when you remove some of the elements, then yeah you remove one of the element what it, like it's better if you remove a maximum thing or a minimum thing to boil the range, yeah, to reduce the range obviously. So how many that you need to remove, so you will remove some, let's say x from this side, y from that side, that you have to tell. Hmm. So that comes down to k, like the difference comes down to k. So this is the current thing. I think it's just a bit greedy, like not greedy. Yeah, you can initially you think about greedy, let's say 20 and 17, the difference I'm reducing is 3, and over here I'm improving by 2. Hmm. Above. Hmm. Then, so it's better to decrease by 3 amount less. But what if now it has only decrement of 1 and very less decrement, but this has more decrement. So let's say this one decrement will give you everything, right? Not You can't even see that this one decrement, if you do this two decrement, will make your work, right? Why you can't see that? Because you are only seeing this endpoints. You're not seeing this 4 9, right? If you make a greedy decision based on these two, like these two values. So the solution will be like to see, yeah, to have all possibilities. What I mean by that is, first you remove from this side, then you see the answer for this range, then you remove from, other option is to remove that, and then see answer for this range, and yeah, that's how you can do it. Yeah, it's a straightforward problem. So this is how we will do this. Okay, let's continue in the next one. Bye.